Okay, come, let's start on this particular questions. Okay, just set 2024. Okay, now, I hope you have done it. If you haven't done it, never mind. As I'm going through, just try to mentally quickly do as I go through it. Okay, now, so let's start on this particular questions. Okay, so question, normally just take note, every single question typically will have one or two. Normally it's about one topic that's being tested and one specific learning objective. But sometimes some questions may cross topics. Okay, so don't be too surprised about that as well. Key idea here is you need to know when we ask a question, typically we are actually testing on a certain learning objective. Okay, so let's look at the first question. Which row shows the most appropriate apparatus to measure the specified quantity in the substance? So actually this one testing on your experimental chemistry, experimental chem. Now, so looking at all these apparatus, I will just strike out those that I know definitely won't be correct. So as I look through all of them, first thing that struck me was measuring cylinder. So measuring cylinder normally not 2 dp. If I want 2 dp, it should be a burette. 2 dp, normally it should be a burette. Okay, so therefore C cannot be the answer. Next one, pipette. Pipette will not have this kind of numbers on. Pipette normally will be a 0.0 at the end. Okay, and normally it's in multiples of 5. Okay, so multiples of 0.5 lah. Sorry, multiples of 5.0. Okay, so normally ends with a 0.0 and it's normally multiples of 5. So that's where D also is out. So I'm left with A and B. Now, next thing I know is that for beaker and gas syringe, I know gas syringe measure gas, okay, correct. Beaker measures solution, also correct. But what I realized is that actually beaker normally not so accurate. If you remember your beaker, the markings, it is 100 cm cube, 50 cm cube. So normally it is not in that kind of setting. Okay, so it's normally not in this kind of like 1 decimal place. So therefore A also is out. So therefore my answer is B. Okay, so if you realize that I'm going through the MCQ, you'll start to realize that my pattern always is to eliminate answer first, then after that I join. Okay. Next one, question 2. Evaporation, filtration, sublimation are carried out in a mixture of sand suspended in an aqueous sodium chloride and aqueous ammonium chloride. So sand is in the solid state. You can see here aqueous sodium chloride, aqueous ammonium chloride. These two are in a dissolved solid state. Okay, so think of it as is a solution. I contain sand, and in the solution here is actually aqueous sodium chloride and aqueous ammonium chloride. So first thing obviously is to filter out the sand first. Once the filtering of the sand is the easiest to do it. So I'm gonna do first step is filtration. So I know C and D is out. Now the next step would be, they say they want to do sublimation. Now after I filtered it, okay, you realize my solution is aqueous sodium chloride and aqueous ammonium chloride. Now, if it is an aqueous state, I cannot do sublimation. Okay, if it is an aqueous state, I cannot do sublimation. So therefore, actually, B cannot be the answer because my second step cannot be sublimation. I cannot sublime a solution. Sublimation is only for solids. Okay, plus also mentioned sublimation. Okay, there are only 3 main substances in your syllabus that you know that can sublime. One is your iodine crystal. The other one is your ammonium chloride, which is listed here. And the last one, which seldom comes out, is your dry ice, carbon dioxide. Okay, so therefore, second question answer is A, because B also cannot be the answer. Okay, I hope you're getting a flow of how I'm going through the questions itself. Okay, next. Question 3. A mixture of gas containing butane, hydrogen sulfide, and nitrogen monoxide, and propane, so there's 4 different gases, is cooled gradually from -30 to -200. So from -30, so -30 is actually a higher temperature, all the way down to -200, which is of a lower temperature. Okay, so I'm looking at gases cooling down. I will not look at the melting point first. I'll look at the boiling point. But then the interesting question is they ask which gas will solidify first. So they're asking which gas will solidify. So actually, you realize, sure, Actually, if talking about solidify, then gas will normally condense to liquid first. Liquid will solidify, right? So let's assume that the gases will turn to liquid before they solidify. So in actual fact, I don't need to look at the boiling point. I don't look at the boiling point. My focus will be on the melting point. And if I look at the melting point, no, most of you whose math cannot make it, it's better if you write down. So negative 86 is actually at the top, followed by negative 138, followed by negative 164, followed by negative 188.
6, 7.
Okay, so let's continue from this. So what you realize is that from negative 86 to negative 188 going down. So you realize for negative 86, it will be the first to solidify. So my hydrogen sulfide will be the first to be solidified. So answer for this one is it's option B. So it's quite fast for this one. Okay, next one. Question 4. Which of the following list of substances contains an element, a compound, and a mixture? Okay, so this is under chapter 5, which element, compound, mixture. Most people will just miss this part because it's like you cover in lower set. But you can see here it's being tested. Okay, so let's just recap a little bit. Those of you who remember your bonding and revised it, this one shouldn't be too tough. Okay, so let's start. So bronze, first thing is, so I'm going to put E, C, and M. So I'm going to classify. Bronze is a mixture, carbon dioxide is a compound, graphite is an element. Okay, so actually, first cut, once I look at this, then A is the answer. But let's look at some of the other options. So carbon dioxide is a compound. Diamond is purely carbon, so actually it is an element. Oxygen, obviously, is also an element because it's not mixed with 2 or more elements, right? So therefore, B cannot be the answer because there's no mixtures inside here. C, dry air. Air is a mixture itself. Sodium chloride, I know is a compound. Water is H2O, so it's a compound. That's why C cannot be the answer. Last one, iodine is an element. Copper is an element. Ice is water, which is a compound, so therefore D cannot be the answer. So for this one, answer is actually A. Okay. Next one. Okay, so the graph shows how temperature varies with time when a substance is cooled at 120 degrees Celsius. Is when a substance at 120 degrees Celsius is cooled to negative 20. So you can see from 120 cool all the way to negative 20. They ask which statement is true. So the particle absorb energy as they become more orderly from S to T. Now, if it's being cooled, actually the particles don't absorb energy. Instead, they actually release energy. So therefore, A is not true. Right? A is not true. Next one. The particles become smaller. Now, in kinetic particle theory, the particles don't become smaller. Okay, the particles are actually all of the same size. So the particles being smaller is a misconception that people always think that when the volume decrease equals particle get smaller, but that's not true. C, the particles release energy as they become closer together from Q to R. So from Q to R is a change in state. So they will become closer together. Okay, and they do release energy. So actually this statement, C is correct. So actually C is the correct answer. But let's look at the last one, D. The volume of the substance decreases from R to S. Okay, the volume of the substance decreases from R to S. So this is the interesting part where we are looking at the volume decreasing because I think there's this idea that there's contraction. But do take note, if you remember liquids, right? The particles are already very closely packed. The particles are already closely packed. So in a sense, if you pull it down, they don't have much space for the volume to contract anymore. Okay, so therefore, if I look at C and D, which is the better answer? Actually, C will be the better answer, D will be. Okay, so just take note of that. So because of this closely packed, and then you know that having the option C, which is actually a better answer, therefore C will be the answer instead of D. Okay, next one, question 6. Carbon monoxide, hydrogen, and nitrogen are gases at room temperature. The rates of diffusion of these three gases are compared. Okay, so I'm looking at comparing the rates of diffusion here. I got carbon monoxide, hydrogen, and nitrogen. So they ask which statement is correct. Now, for this one here, it'd be better if I want to write down the chemical formula, because most probably if I look at rate of diffusion, there could be two things they might compare. One is temperature, the other one is comparing MR. Okay, so now I look at all the statement they ask, okay lah, I think I need to calculate MR already. So CO will be 12 plus 16, that will be 28. Hydrogen is just 2, nitrogen is just 28. Okay, so question 6, let's look at the options. Carbon monoxide gas and nitrogen gas diffuse at the same rate. Actually, answer is yes, it's just A already, because can you see MR is the same, so their rate of diffusion is the same. Now, carbon monoxide gas diffuses the most slowly. That's true, but if I want to write here, down here should also include N2 as well. Okay, so therefore B is not totally correct, because N2 should be included there as well. Hydrogen gas diffuses most quickly as the highest average kinetic energy. Now, this average highest kinetic energy has to do with the temperature. Okay, so but you realize that in this particular question, it diffuses most quickly because, not because of the temperature portion, it's really because the MR is the lowest. Okay, so this is a comparison of MR, and hence it shouldn't be using the highest average kinetic energy as a way to explain this part. So therefore C will be the answer. Last one, nitrogen gas diffuse most slowly as not chemically reactive. Now, if it's chemically reactive, it can still diffuse. It's just that along the way it will react on other things. So this is actually not a suitable explanation in terms of the rate of diffusion as well. So being very clear on what affects the rate of diffusion in this question 6 will help you to zoom in on the proper answer as well. Okay, so that's for question 6. I'll pause at question 10 for you to consolidate and take note of the different things as well. Okay, so right now I'll just be going through one after the other. Okay, but I'll pause at question 10 just for you to consolidate. Okay, next, which statement about atoms is always correct? So this is about atoms. Okay, and they say it's always correct. Atoms of different elements have different number of neutrons. Actually, different elements, they are supposed to have different elements are supposed to have different number of not neutrons but protons. So if you realize that different elements, the proton number will be different. For this one, you will get your periodic table, so don't worry. Okay, you have your periodic table in the exam for the paper one. Okay, sorry, back to this. So different elements will have different number of protons, not neutrons. So take note. Therefore, A is not correct. Now, atoms of the same element are all identical. When they say identical, what do you mean? Actually, one way to look at it is it means that they have the same number of subatomic particles. Okay, now for them to the same number of subatomic particles, we are looking at the proton being the same, the electron being the same, the neutron being the same. But you know that this is not true, because why? Isotopes, they have the same number of protons, same number of electrons, but different number of neutrons. So therefore, they are not identical. Okay, so atoms of the same element could be different because they could be isotopes. Okay, because they are atoms, they are actually electrically neutral. Okay, because they're electrically neutral, so proton equals to electron. Therefore, the number of electrons equals number of protons. This is the correct answer. Okay. Now, the valence electron shell contains the least electrons. This is not true. Why is it not true? Because remember, the innermost shell, which is your first shell, actually maximum only can contain 2 electrons. So actually your group 13, group 14, group 15, actually all of the valence electron shell actually contains more electron than the first shell. So therefore D is also not true. Therefore answer is C. Okay, next one. An isotope element Q can be written as 3216Q. Okay, 3216Q. So let's look at Q itself, the isotope. So 3216. Since they're asking me to compare protons and electrons, I better go and write down the thing. So proton, I know that it will be 16 because it follows a smaller number. Electron, because it's an atom, so the electrons will be the same. 32, so that will be the proton plus neutron, so neutron must also be 16. So Q has 16 protons, 16 electrons, 16 neutron. Okay? They say particle R has 4 more neutrons. So R, I know that has in terms of proton, electron, neutron. They have 4 more, so it will be 20. 1 more proton, so it's 17. And 1 more electron, so this will be 17. Okay? So in this case here, R will be the chemical symbol. Proton will be at the bottom, so that will be 17. Proton plus neutron will give me the top, so it will be 37. Then the last one for this whole thing here is to know whether does it have a charge. Because proton and electrons are the same, so therefore down here the charge will be 0, which means that there's nothing there. So therefore, out of all the answer, my answer will be D over here. Okay? Next. Y and Z forms ionic compound of formula YZ2. What could be the proton number of elements Y and Z? Now, because it's ionic compound, so it should be metal and a non-metal. Normally, when you write a chemical formula, Y should be a metal. The second one should be a non-metal. So that will be the order that normally you write your elements. Okay? Now, next thing I will know from the formula is that if it is a YZ2, how do I get this? It's actually by crossing over the valency. So I know that because it's YZ2, my Y will have a valency of 2. My Z actually has a valency of 1. Okay, that's why when you cross over, you can get YZ2. So what I'm going to do here is, what could the proton numbers of Y and Z be? I will look out for those that are, I'll check out what elements they are, because I know the proton number. So Y, if it is 8 protons, it will actually be oxygen. 11 will be sodium. 12 will be magnesium. 16 will be sulfur. So I know that A and D cannot be the answer because Y should be a metal, right? Next, Z. So lithium, oxygen, this is fluorine. This will be chlorine. So actually I know A is out already, so I can forget it. D I know is out already, so I can forget it. So I know Z has a valency of 1. So therefore, I know oxygen cannot be the answer because oxygen valency is 2. So therefore, my only answer left is C, where Mg has a valency of 2. Fluorine has a valency of 1. When you do the crossover, you actually get MgF2, which is YZ. Okay? Next one. Question 10. Okay, after this, then we'll take a short break, about maybe 2-3 minutes. Okay, the structure of propanoic acid is as shown below. So this is the structure of propanoic acid. How many electrons are not used for bonding in each molecule of propanoic acid? So I want the ones that are not used. Okay, how to go about doing quickly for this? So just take note. In your periodic table, you will know how many valence electrons there are. You will also know their valency. Okay, so for hydrogen, how many valence electrons does it have? 1. What's the valency? 1. Carbon, what's the number of valence electron it has? 4. What is its valency? 4. Oxygen, what's the valence electron that it has? 6. Valency is 2. Now, why are these numbers important? Because valence electrons is the number of electrons in outermost shell. Okay? Valency is the number of electrons used for bonding. So if I look at all of this, they all have bonded properly. So in actual sense, you can see here hydrogen, valence electron 1, 1 electron used for bonding. So how many electrons that it has unbonded? So this part here will be the unbonded electrons. So I'm going to write inside here. So if I got 1 valence electrons, 1 used for bonding, so 0 valence electrons left. Okay, that's unbonded. Same thing for carbon, 4 minus 4, 0. Oxygen, you realize I have 4 valence electrons not used for bonding. So in actual fact, what I know is that if I got 4 electrons from oxygen not used in bonding, I got 4 electrons here not used for bonding. So therefore, answer should be 8. So I'll say here, answer is 8. But this is where the trick in this particular question comes in. Okay, 8 is actually not the correct answer. Now, why is 8 not the correct answer? Is because, remember, carbon is C612. 6 means I have 6 electrons. which means my electronic configuration is 2, 4. Whatever that I've mentioned in terms of valence electrons doesn't include the inner shell. And the inner shell is definitely not used for bonding, right? So hydrogen is already the outermost shell, right? Whereas for carbon, I got 2 in the inner shell, not used for bonding. 2 in the inner shell, not used for bonding. 2 not used for bonding. Oxygen, same thing, is O8, 16. So there's 8 electrons, so it's 2, 6. So you realize there's also that 2 inner shell, not used for bonding. So for oxygen here, it's a 4 in the outermost shell, plus 2 in the inner shell. Same thing, plus 2 in the inner shell for here. So you add up all of them, the answer will be 18. Okay, so I will tell you that safely, question 10, okay, it's actually a very poorly done question back in 2024. Okay, about only 40% of the cohort got it correct. Those who got it correct, most probably have done their TYS and done previous year's questions, and they realize this is what comes out. Okay, so the question 10 was quite badly done in 2024. Okay, so now we are done with the first 1/3 already. Right now, just go and consolidate all we have done. As I mentioned, this will also be uploaded as a video as well. So if you need to check back on any one of this, just make sure that you can go and watch the video. Okay, that's the first thing. Second thing, as I mentioned, you should. I hope you have done this already. That's why I'm going through quite fast. So it's really for you to check your answers to make sure that where your steps have gone wrong, if you got it wrong. Okay, but of course, if you got it correct, then just listen to me going through this will be sufficient. Okay. So valence. I saw a question that came in. So one of you asked is if valency, what is valency? So valency is actually the number of electrons used for bonding. It can be the charge, but it can also be, but I wouldn't say it's totally for the charge as well, because valency can be used for covalent bonding. Covalent bonding is not really a charge, it's the number of electrons that forms that covalent bond. Okay, so just take note of that one. Okay, 1 more minute, then I'll carry on with the question 11 onwards. So take a short time, 11. How to tell valency from the periodic table? Those of you who do not know, it will follow that 1, 2, 3, 4, 3, 2, 1, 0. So similar to those of you who always write the +1, +2, +3, +4, then -3, -2, -1, 0. That is also the valency. So just remove the plus and the minus, the number itself is the valency. Okay?
Sorry, Mr. Eugene.
Tomorrow morning we go gym, you all following or not?
Sorry, how do you know how many electrons are used for bonding? Like for the C, right, it's connected to 3 hydrogen on the left side. So how would it still have 2 left?
It's actually connected. Okay, so you see for this carbonate, there's 1 bond, 2 bond, 3 bond, 4 bonds. So in terms of it has 2, 4, right? The 4 electrons are used to form that 4 bonds. So there's no outer shell electrons left. The 2 actually is from the inner shell, which is not involved in bonding. So the 2 is not because of the outer shell. The 2 is because of the inner shell. Can?
Okay, sure, got it. Thanks.
No problem. Okay, let's go on question 11 now. Which substance does not contain covalent bond? So actually, this is a bit of like a semi-trick question. So if you look at all of this, most people will gonna stun because why? You only know that this is silicon dioxide. This is the only covalent substance. So I know C contains covalent bond, so therefore C cannot be answered because it does not, right? Then it's ionic. So this ionic, this ionic, this ionic. Then how can it be that they do not contain covalent bond? Okay, how can it be that they contain covalent bond? So take note, ammonium, look at it carefully, is NH4+. How did the N and the H form bonds? So do you realize N is a non-metal, H is also a non-metal. So for NH4 to form, actually internally, it is a covalent, they have covalent bonds inside them. So actually A, the ammonium contains covalent bond. Okay. Next one, nitrate is another one because it's NO3 minus. Can you see N and O? So non-metal, non-metal. So the way how the N and the O bond is actually also through covalent bonds. So in the ionic compound itself, the complex anions or the complex cations actually contains the covalent bonds. So therefore, B contain, so therefore it's not the answer. A contain, so it's not the answer. Therefore, answer is D. Okay? So that's for question 11. Question 12. How many statements are correct for both metals and ionic compounds? So correct for both are pure compounds. So answer this is wrong, yeah, because metals, they are generally elements. Or if they are alloys, then they are mixtures. So they are not compounds. So therefore, the first statement is wrong. Second statement, okay, they conduct electricity as electrons flow through the solid material. For solid and for electrons to flow, this is only metal. Okay, cannot for ionic. So therefore, this one also cannot be answered. So first two statements definitely not correct for both. They contain metal ions held by strong attractive forces. So do they contain metal ions? Metal, there is cations. Ionic compounds, they also contain cations. So both have metal ions. And both are actually held by strong electrostatic force of attraction. It's just that one is between N ion and cation. The other one is the sea of delocalized electrons with the cation. So therefore, third statement is correct. Next one, they generally have high melting point. Obviously, if they have strong attractive forces, they have high melting point. So therefore, answer for question 12 will be wait, yeah, his answer should be B. Wait, let me see. B, C, 7, 1. Okay. Sorry, this one is wrong. So for question 12, let me go and clarify. Because this one here, from my understanding, 2 should be correct because they do contain metal ions which are catch ions. They are held together by strong attractive forces. But in my answer scheme, question 12, the answer is A, which is 1 only. So this one, let me go and clarify. Okay, this one, let me go and clarify. I'll let you all know by Monday, okay? So this one, my bad. This one, I put a question mark for you. But I hope you understand the rationale of my explanation. Okay, next, question 13. Which statement about diamond and silicon dioxide is correct? Okay, for this one, every atom is bonded to 4 other atoms in the structures. This is correct. Okay, so question 13, is it? Which diamond, no, correct, wrong. Because silicon dioxide, silicon is bonded to 4 oxygen, but then each oxygen is bonded to 2 silicon. So therefore, this one is wrong because not every atom, the O is not. So A is wrong. Next, they are electrical insulators as all the electrons are involved in bonding. So we do know that diamond and silicon dioxide cannot conduct electricity. So this is okay, so question 13. Electrical insulators as all the electrons are involved in bonding. Okay, sorry, this one is a trick question again because not all the electrons are involved in bonding. You still got an inner shell. Inner shell not involved in bonding. So this one is damn tricky. So actually B is also wrong. Okay. Next, they are hard as they contain a network of many strong covalent bonds. So we do know that sand and diamond itself, they are actually hard. So therefore, actually C should be the correct answer. Let me just double check D. They have high melting boiling points as they contain strong electrostatic force of attraction between ions. Between ions, obviously wrong. This is giant covalent, so there's no ions present. So therefore, answer will be C itself. Okay. So B, I realize in this one here, B is a common error. Okay, B is a common option that a lot of students picked. But because they like what I did, I do B, I do C, then I realize A both like correctly. So in the end, that's where you realize that the all electrons is the one that is the distractor. So it's the one that helps you to know that it is wrong. Okay, next one, question 14. 20 cm cube of ethene is reacted with 70 cm cube of oxygen as shown in the equation. What's the total volume of gas remaining at the end of the reaction? So I got 20 cm cube of ethene, so I got 20 cm cube. I got 70 cm cube of oxygen. Okay, then they'll react. Now, because they are both gases, I can just use direct proportion in terms of the amount of gases. So if I got 20 cm cube of C2H4, okay, what's going to happen is that 20 cm cube of C2H4 is supposed to react with 60 cm cube of oxygen because it's a 1:3 ratio. Okay, so I do know that O2 will be, since 20 cm cube will react 60, it tells me that O2 is the excess gas, is the excess reactant. So there will be left over 10 cm cube. Okay, so left over, there will be 10 cm cube. Next, if I got 20 cm cube of C2H4 reacted, because the ratio is 1:2 for the carbon dioxide, ethene to carbon dioxide, so I know 40 cm cube of carbon dioxide will be produced. So I have 40 cm cube over here as well. Okay, because this is the total volume of gas remaining. So I got 10 cm cube of oxygen, 40 cm cube of carbon dioxide. Last one, water. Oh, it's a liquid, so I don't care about this because I only want the volume of gas. Therefore, answer for this one will be 50. Okay. So this is a limiting excess reactant question. So there's a limiting reactant and excess reactant, limiting and excess question. So let's just take note of this. Okay, so the good thing about this kind of question when they ask you about volume of gases, you can always just use the volume, you can just compare the volume ratio. You don't need to convert, like divide by 24, divide 24,000 to find the number of moles. Okay, that's a good thing about question 14. Can use the volume ratio. Next, question 15. Which substance contains the same number of atoms as 9 grams of water? So to know that they have the same number of atoms, I definitely must split it up further. So let's find first, in 9 grams of water, how many atoms do I have? So first thing, 9 grams of water is 9 grams of H2O, right? So first thing, let's find mole. Okay, how many moles of water? So 9 grams of water, it'll be 9/18 H2O, moles of H2O. Mole of H2O. So it's 0.5 mole of H2O. Okay. Now I know that there's 0.5 mole of H2O. In case some of you asking where 18 is from, 18 is the MR of water. Okay. Now 0.5 mole of water. So one molecule of H2O, one H2O actually contains 3 atoms. Okay. One molecule of H2O contains 3 atoms, 2H plus 1O. So if it was 0.5 mole of H2O, means that there's 1.5 mole of atoms. Okay, 1.5 mole of atoms. I'm not going to multiply by 6.02 times 10^3 because all my numbers will look very crazy. Just know that mole is actually sort of like a condensed version of 6.02 times 10^3. So I'm just going to leave it as mole and not times. So I know that I was fine. 1.5 mole of atoms here. Now let's look at 6 grams of hydrogen gas. So hydrogen gas is H2. So I know that if I got 6 grams of hydrogen gas, I'll need to take 6 divided by 2. So I got 3 mole of H2, which means that this will actually be 6 mole of atoms. So obviously it's wrong maybe. 14 grams of nitrogen gas. So nitrogen gas is N2. So this will be 14 divided by 28. Take note all the number I divide at the bottom here is the MR. Okay, so 14 divided by 28 is 0.5 mole of N2. And if it is N2, this means that this will be 1 mole of atoms. Okay, it's just times 2, then you got 1 more atom. So I know D cannot be the answer. Next, 21 grams of carbon monoxide gas. So 21 grams of carbon monoxide gas. So carbon monoxide is CO. Okay. So this will be 21 divided by 12 plus 16. So that's 28. So 21 divided by 28. Let me do this calculator. 21 divided by 28. So I got 0.75. 0.75 mole of CO. And if I got 0.5 mole of CO, one CO got 2 atoms inside. So if I multiply by 2, I'll get 1.5 mole of atoms. So actually realize, sure, C is the answer. But let's just double check. Okay, so 44 grams of carbon dioxide gas. Carbon dioxide is CO2. So I got 44 grams divided by 12 plus 32. So it gives you 44. So you get 1 mole of CO2. This one here, you must multiply by 3 because it's CO2. One CO2 contains 3 atoms. So I got 3 mole of atoms here. So therefore, D cannot be the answer. B is not, A is not, answer will be C. Okay. Next one, question 16. 8 grams of impure sample of copper 2 carbonate is heated and 800 grams of carbon dioxide gas was collected. So take note, this 8 grams is impure sample. That's why they want percentage purity. So they tell me 800 grams of carbon dioxide gas is collected. So I'm going to, from carbon dioxide gas, find the amount of copper carbonate present. So I'm going to go from volume of CO2. I'm going to find the mole of CO2. Then I find the actual number of mole of copper carbonate present. Then I convert to the mass of copper carbonate. Once I find the mass of carbonate present, then I can take, this is actually my actual CuCO3 in sample. Okay, let's call it X. Then after that, with the X there, I'm going to take X divided by 8 times 100. Then I can get my percentage purity. Okay, so let's do the working here. So in terms of volume of gas, I want to find the mass. So I'm just going to do shortcut, mass of CuCO3. So I'm going to take 800 divided by 24,000 because volume to mole, I'm going to divide by 24,000 cm cubed. Mole to mole, I use mole ratio, which is times 1/1. So I'm going to times 1/1 here. Then mole to mass, I'm going to times the MR, which will actually be 64 plus 12 plus 48. Okay, so I'm going to press my calculator for this. 800 divided by 24,000 times 1/1. Then times 64 plus 60. So you're going to get 4.13. So that's the mass of CuCO3. Then the 5 percentage purity, let's sub it in. 4.13 divided by 8 times 100. Divided by 8 times 100. So you're going to get 51.7% as a 3SF. So answer for question 16 will be a C. Okay. Next one. A compound only contains 3 elements, carbon, hydrogen, and oxygen. When 11 grams of the compound was analyzed, it's found to contain 4 grams of oxygen, 1 gram of hydrogen. What's the empirical formula? So empirical formula, this one here, you know lah, is really just do the table. So mass-wise, okay, so I got carbon, oxygen, hydrogen. Oxygen 4 grams, hydrogen 1 gram. Carbon will be the remaining of the 11, so that will be 6. So I'm gonna first thing take the AR, which is 12, 16, and 1. I'm going to take mass divided by AR to find the current number of moles. So 0.5, 0.25, and 1. So obviously the ratio here, I look at all these numbers, I'll multiply 4 throughout. So it's in 4, 1, 2. Okay, to get from here to here, I'll just multiply 4 throughout. Or the other way is you just divide by 0.25, we should get the same answer. So based on this, it'll be C2OH4. C2OH4. So answer for question 17 is B. Okay, so B is really just a simple empirical formula calculation. Just have to get used to the steps. Okay, next one, question 18. So question 18, a mixture of copper and zinc is added to an excess hydrochloric acid. The resulting mixture is then filtered. Which observation is correct? So in this particular question here, they tell you there's a residue and filtrate So why is there residue and filtrate? Is because copper is an unreactive metal. So if it's an unreactive metal, means it won't react. So I'm supposed to expect a residue. Okay, so therefore B and C is not the answer because I know our copper left. Okay, now then in terms of solution wise, zinc will react to give me zinc chloride. Okay, so I know because zinc chloride is present, blue solution is for copper solution. It's a copper 2 solution, copper 2 plus solution. But I know copper 2 did not react, so A cannot be the answer. Therefore, answer should be D, which then tells you that this reddish brown color solid is actually your copper. So pure copper can actually be sometimes described as a pinkish brown or reddish brown solid. Okay, if you can see your wires at home, those wires that you don't want, you go and chop open, you realize that inside the copper color is actually very nice pinkish brown or reddish brown kind of color. Okay, this colorless solution is actually a zinc chloride over here. So that's for question 18, knowing that which acid will which metal will not react acid, and that's how you get to the answer. Okay. Next one. Question 19. A substance was added slowly to aqueous sodium hydroxide. The pH of the resulting mixture slowly decreased. Okay, the pH of the mixture slowly decreased. So this is a interesting question because why? Normally when you add sodium hydroxide, because you know this alkaline, means that you expect the pH to increase. So something must be reacting with it and causing the pH to be decreasing. Okay? So that's for the understanding of question 19. Sorry. I read a question only, my bad. Going too fast. Sorry. Okay, I reread this one again, my bad. So a substance was added slowly into aqueous sodium hydroxide. So that means initially the pH is about 13/14. I added a substance in, so I added this substance in, and then the pH is decreasing. That means I know that some sort of neutralization or / reaction is happening. Okay? So which row shows substances that could have caused the decrease? So I do know that if I add acid, confirm cannot, the pH will drop. Okay, so I know this two looks possible. Okay. Next thing I know is question 19 is aluminum oxide, sulfur dioxide. You realize all almost left with oxide. Okay, so let's look at this one here. Aluminum oxide, I know is an M4 ferric oxide. So I know that it will react with alkali. So actually this one can. Sulfur dioxide is an acidic oxide. So I know that it can also react with my sodium hydroxide to neutralize it, to make it more to make the pH drop. So therefore actually A is the answer. Let's look at B. Acid works, but carbon monoxide is a neutral oxide. So it doesn't react. So B cannot be the answer. Next one. Nitric acid plus potassium oxide. Potassium oxide is a basic oxide. So because it's a basic oxide, actually you realize, this one doesn't react with my sodium hydroxide. Instead of decreasing the pH, it might actually make my pH increase. So therefore, C cannot be the answer as well. Next one, zinc oxide is M4 ferric. So actually this is good. Okay, M4 ferric oxide. So you will react with my sodium hydroxide to make the pH decrease. So therefore, zinc oxide can. But calcium carbonate, you realize alkali don't react with carbonate. So therefore, this cannot be the answer. D cannot be the answer. Answer will be A in this case here for question 19. Okay. Last part before I take another break. Question 20. The table gives information about 3 indicators. So I got Thymo blue, Congo red, phenolphthalein. They tell you the color at pH 1, color at pH 12, and the pH which changes color. So actually, what does this table tells you is that P changes color, right? So anything less than 3 is red. Anything more than 3 is yellow. Okay? So same way for this one here, anything more than 5 is red. Anything less than 5 is blue. so and so forth. Okay, which colors would be obtained when each indicator was added separately to pure water? So pure water, is pH 7. So ask ourselves, where is water, right? So let's use blue color to indicate. So you see Thymo blue, the pH changed color at 3, right? So therefore, it will be yellow when it is in pure water at pH 7. Next thing, for Congo red, blue color if it is less than 5, red color if it is more than 5, so therefore it will be red. Phenolphthalein, below 10 is colorless, above 10 is red, so therefore it will be colorless at pure water. So therefore answer will be yellow, red, colorless. So answer is D. Actually the Congo red is a giveaway lah. Okay. So question 20, answer is D. Okay. Okay, let's take another 2-3 minutes breather break again. I consolidate, then we'll carry on the last 10. I'm going faster because my assumption is that you should have done the questions already lah. So if you are doing it fresh on the spot, you realize I'm going through them fast. It's your first time reading a question, so you might not be able to catch up. So those who can't catch up one, okay, do take note, you can go back and watch the video just to understand the train of thought of how I went through the answers. Okay, we will carry on at 47, okay? So got 1 more minute. Okay, last 10 questions really. #21. Okay, the following substance are reacted with sulfuric acid separately. So they are looking at all of these reacting with sulfuric acid. How many pure insoluble sulfates will be formed? So insoluble sulfates, then what you know is an H. This one seems like a salt question. The answer is yeah lah, it's a salt question. So I want insoluble sulfates, I want it to be pure. So I know that I just look at the metal with the sulfate lah. So iron sulfate, I know it's soluble. So therefore it's not insoluble. So this will be out. Potassium don't even need to see because potassium, you know that confirm soluble one. So this is out. Next one, lead 2 carbonate. So I'll form lead 2 sulfate. So actually A, this one seems okay leh. But what you realize is that when lead 2 carbonate is a solid, this is the case where I got a block. So imagine this is my lead 2 carbonate. When it reacts with my acid, my lead sulfate will form a layer around it. Which then, if I let it react, it will stop after a while. Then the question is, you realize that it will not be purely lead 2 sulfate. My solid will contain lead 2 sulfate plus also PbCO3, which is lead 2 carbonate. Because not all the lead 2 carbonate will react due to the insoluble layer that's being coated around. So therefore, this one cannot be the answer. Next one, barium chloride. So barium, forms a solid with sulfate. I can form barium sulfate, which is an insoluble salt. Therefore, this can be the answer. Copper solid, nope. Copper doesn't even react acid, so this cannot be the case here. Aqueous calcium hydroxide. So I know that aqueous calcium sulfate can form a calcium sulfate is an insoluble salt. So I know that this can be the answer. So therefore, I only got calcium hydroxide that will work and barium chloride that will work. So question 21, answer will be A. Okay. Question 21, answer will be A. Next one. Question 22. The following statements about dilute sulfuric acids are all correct. Okay. Which statement confirms the acidic nature of the solution? So I want an acidic solution. I want to make sure that it's talking about acidic nature. So question 22. First one, white precipitate is formed when barium chloride is added to the acid. Now this white precipitate is formed because it forms barium sulfate. It is because this is an insoluble salt. So you realize that, this is not a property of acid, right? Because acid react with metal, carbonate plus base, right? So these are the chemical properties. Plus also I can think in terms of the physical properties as well, in terms of litmus paper, sour and whatsoever. So I know one is not correct because it doesn't confirm the acidic nature. Okay, next. So next one, copper 2 oxide dissolves in acid to form a blue solution. So this is a base. Dissolve in the acid means it reacts with acid. Okay, question number 2 seems to be like a possible answer. Okay, possible answer. So let's put a tick here. Sodium chloride dissolves in acid to form a colorless solution. Like, sodium chloride, isn't it a salt? Salt dissolves in the acid. No, this is not an acid reaction. This is just because sodium chloride is soluble in water, right? Acid contains water. So therefore, 3 cannot be the answer. Then the last one is acid turn universal indicator rate, clear cut. This is the answer. So if I look at all the options, I know that 1 is confirmed out, so I know that A and C is out. I look at all of this, I know that 3 is out. So therefore, answer left is B. Okay, so you realize by elimination, you can get the answer. Next one, which salt can be prepared by titration method? Titration method generally look out for SPA, or you can think of group 1 / ammonium salts. So you realize actually all this, the only answer 23 is A. Because this is not SPA, this is not group 1. Okay, so therefore all these 3 cannot be the answer. Okay, so I think 23 is quite straightforward. 23 actually quite well done in the cohort. Okay, next one. Question 24. Some statements about ammonia are shown below. It dissolves in all solvent to form hydroxide ions. So question, all solvents, like question mark. So you know that alkali typically you say dissolve in water to give hydroxide ions, right? So this all solvents here, actually you realize that in your under chemical bonding, we got talk about this other solvent called organic solvent. So no lah, it doesn't dissolve in all solvents. Actually, okay, it doesn't dissolve in organic solvent, only dissolving water to form hydroxide ion. So therefore 1 is not correct. Next, it is produced when ammonium carbonate react with dilute nitric acid. This is gonna give me ammonium nitrate, carbon dioxide gas, and water. So, no, right? It doesn't give you your ammonia gas also. Next, ammonium nitrate warm with calcium hydroxide. This one can, because I know that alkali plus ammonium salt can give me my ammonia gas. Okay, so therefore 3 is correct. Next one, it turns methyl orange indicator yellow. So yellow is because it's in an alkali solution, and we know that ammonia itself actually is alkaline by nature. So for question 24, you realize that the answer in this case will be my B. Okay, it'll be B because only 3 and 4 is correct. Okay, next one. Question 25. 2 bottles of solution in the lab are unlabeled. 1 bottle is suspected to contain sodium iodide, the other contains sodium sulfate. So if you look at these two, actually it's the iodide and the sulfate that's different. So I'm just comparing I- versus SO4 2-. Which of the following cannot be used to distinguish? So cannot be used to distinguish the solution. So first thing, I add barium nitrate. So barium nitrate, you know that it will form barium sulfate, which is a white PPT. Now obviously iodide, you know that BAI2, right? What nonsense, right? So you know that first one can be used to distinguish. So therefore, it is not the answer. Okay. Next one, calcium nitrate. Actually, you realize that calcium nitrate same as the barium sulfate thing lah. I can form calcium sulfate, which is the white PPT, which is an insoluble salt. Calcium iodide should be soluble lah. But even if it forms some salt, it should be yellow in color. So therefore, this one can be used to distinguish. Therefore, it is not the answer. Next one, silver nitrate. You know that silver nitrate? Cannot, because I know that AGI is a yellow PPT. Okay. Sorry, lag. It's yellow PPT. Then obviously my silvers, my AgSO4, most probably will be some other Ag2SO4 will be some other color. So therefore I know C can be used to distinguish. Therefore C cannot be the answer. Therefore I'm left with is D. So you realize when you have dilute sulfuric acid, you're just adding SO4 2 minus and H plus into the solutions. That doesn't help you to precipitate, or that doesn't have any reaction to show you that there's a difference. So therefore 25, sulfuric acid cannot be used to distinguish between them. Okay. Next one. Aluminium sulfate is sometimes used in water treatment to remove impurities. The aluminium sulfate is acidic. Aqueous hydrogen is acidic. Excess aluminium sulfate is added to water sample. The water sample is then separately tested for pH and mixed with excess aqueous sodium hydroxide. Which of the following shows the correct results? So I added in excess in the water sample. It is then tested for pH. So you know that it is acidic. So therefore I know C and D cannot be the answer for question 26. Because it must be pH 3, cannot be 7, cannot be 11. Next, when I add it to excess aqueous sodium hydroxide, take note excess. So I know that for Al3+, it will form a white PPT, but then it will dissolve in excess. So after it dissolves in excess, it actually gives you a colorless solution. So therefore, answer will not be B because it won't be just purely, you won't actually have a white PPT if add excess. It will just be purely a colorless solution. So therefore 26 is B. Next one, when aqueous ammonia was added to solution P until in excess, a precipitate which was formed, which then decreased in quantity. So a decrease in quantity actually tells you that it's dissolved in excess. Okay, dissolved in excess. So first thing must form PPT, so I know B is out because calcium don't even form PPT. Next, which PPT will dissolve in excess? So I know that Fe3+ won't dissolve in excess. I know Al3+ in aqueous ammonia won't dissolve in excess. Therefore, answer will be Cu2+. Because Cu2+, it will actually form a blue PPT. Okay, which will dissolve in excess to form a dark blue solution. Okay, so that's for question 27. So these are my QA question again. Question 28, which of the equations shows redox? So let's look at these equations here. So what I'm going to do is I'm going to do my redox in terms of the change in oxidation state. So O is a minus, there's no element. So I'm going to apply O is -2, O here is -2. Okay. I know Ca is a +2. I know down here Si is a +4. I know that this is calcium silicate. So calcium silicate, this will most probably a +4 and then a +2. So I know there's no change at all in terms of oxidation state for A. But those of you who cannot figure out this one, you can just put a question mark first. We sort out the rest. Okay. Next one, Mg, 0. H is a +1. Therefore, Cl must be a -1. Mg here is a +2. Cl is a -1. H is a 0. Actually, you look at B, clear cut. B is a redox. I just circle B here. So A, even though I do not know, actually B is quite clear cut because the magnesium from oxidation state 0 became a +2. Therefore, this must be a redox reaction. Okay, the other two, you can go and do your oxidation state. You realize that there's no change in any of this. A few things to note. This one is actually a neutralization reaction. Okay, this one here is a precipitation reaction. That's why I mentioned to you, these two actually are not redox reaction, therefore C and D also is out. Okay, A is the only odd one out. But A actually you can also decipher because why? CaO is actually a basic oxide. SiO2 is actually an acidic oxide. So you realize this is similar to a neutralization reaction as well. Okay, because I got a basic versus a basic reacting acidic. Okay, next one. Talc is a mineral, has a formula Mg3 blah 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 blah. What's the charge of Si4O10? Now they purposely very nice put a bracket for you, so it makes life easier for you. Now take note, Mg, I know it's a 2+. Okay. I got 3 of them, so the total charge is a +6. OH is a minus. I got 2 of them. So the total negative charge is a -2. Now, Si4O10, it is clustered together, right? I only know 1 of this. Now look at the overall charge of this fella. The overall charge is 0. Therefore, +6 plus -2 plus whatever this fella is, the overall charge must give me 0. Okay, so if I just do my math, x will actually be equivalent to -4. So question 29 is D. Okay, and last one, the reaction between potassium iodide and peroxydisulfuric acid, this whatever rubbish this is as shown below. What's the role of H2S2O8 in the reaction? Now, take note, potassium iodide. This you know is a reducing agent. Potassium iodide is a reducing agent. Now, for the reducing agent to react, actually how you know, can you see this -1, this is 0, right? So you realize that the Ki itself is oxidized. It comes as a pair, right? 1% is a reducing agent. So if this guy is a reducing agent, that means this guy must be an oxidizing agent. Okay, so therefore answer is B. Now, why it cannot be a base? Why it cannot be an acid? Because Ki is not an acid or a base. Neither is it like a basic oxide or acidic oxide. So therefore, A and C, and it's not a carbonate, it's also not a metal. You realize that there's no reaction that a base and acid react with it. Next thing, you know that Ki is a reducing agent, therefore it won't react with another reducing agent, therefore B is also out. So therefore for question 30, answer will be D. Okay, because reducing agent and oxidizing agent comes as a pair. Okay, so that's all for question 1 to 30. I'm going to stop the recording already. Okay.